Welcome to queenon7.com. Please share, like and comment on my videos. Today we're going to look at the naming benzene and its derivatives. If you remember, in the last video we have talked about the structure of benzene, where we have talked about the delocalization of electrons inside the benzene ring. There are three types of benzene derivatives we're going to discuss. If you have a simplest molecule, for example, if you have a benzene with a delocalization, this is how you actually show the delocalization. If you have, for example, chlorine, you will just write it down, the name of the substituent on the benzene ring as chloro, and then benzene as it is. And same goes for nitro. If nitro group is attached, you can say nitrobenzene. For the simplest molecule, it's pretty straightforward, it's pretty simple to do it. But when you talk about when you have substituent more than two or more than two, and also when you have two same substituents are present on the benzene ring, we're going to look at that as well. So if you have a substituent on the benzene ring, like for example, if you have chlorine and then you have a methyl group attached to benzene, you will write down the minimum position for both of them on the benzene ring. If I actually pick chlorine from there, because chlorine has started with C and methyl start with M. So when you name these substituents, you will actually write them down in the alphabetic order. And alphabetically, chlorine will be given number 1 position. If I go through this way, the methyl will have position number 5. And if I go through this way, it will have the position number 3. So it is just same like when you actually talk about the aliphatic hydrocarbons. How do you name them according to IUPAC system? You will give them the minimum numbering. Second law is you actually obviously give them the name or based on the alphabetic order. So I will take chlorine first. So number 1 is the position for chlorine. So 1 chloro, and then you have 1, 2, 3 methyl benzene as it is. So the simplest molecule and the substituent molecules will have the same thing common, which is benzene. If I go a little bit forward, if I actually pick, for example, a benzene ring with chlorine, and then I have CH3, 2 methyl group. Now you're going to name in the same way. Alphabetically, chlorine will come first, 1 chloro. Then you will use a prefix di, tri, as for how many of them are present. So at the moment I have 2 methyl groups, so I will use a di prefix. So I will say 1 chloro, then 3, 4 and 5. So 3, 5 di methyl, and then you write it down benzene as it is. This is for the 2 or more substituent. Some of the molecules, it gets complicated when you look at the structure of benzene in a way where benzene actually is being given the name as a substituent. Rather we call it as aminobenzene, we actually call it as a phenyl. Now if you do remember, CH4 is the formula for methane, and if you take 1 hydrogen off, it is methyl. So based on that, if we consider this molecule, this is C6H5. C6H6 is the molecular formula for benzene, and you remove 1 hydrogen, we are going to call it as phenyl. Phenyl, and then obviously, that's the formula, so we call it as phenylamine. So this is how you're going to represent them. Now, talk about the reactivity. I'm going to upload another video after that, where we're going to talk about the reactions of the benzene with different reactants. If you look at the reactivity, benzene does have some sort of delocalization inside the benzene rings, apart from the single bond between carbon and carbon. Even though it has some extra bonding on top of each carbon due to the parallel overlapping of p orbital, it's still not gonna adapt the same reactions as alkenes, it is not going to get into the addition reaction. It will prefer to have a substitution reaction. The substitution reaction is because the benzene will have less electron density as compared to alkenes, so they will not actually allow any addition. For example, if you do remember, if I remove this, in alkenes, when they react with the bromine water is like an orange and brown color solution, it get decolorized because it will undergo the addition reaction. So each of the carbon will get one bromine atom, and that is called addition reaction, electrophilic addition reaction. But in benzene, addition is not going to happen, so benzene will prefer to undergo substitution. Each carbon has got one hydrogen. Now the bromine will actually be polarized by this electron density between carbon and carbon double bond. But because of the delocalization, it is not going to polarize it, so the electrophile as Br positive can come out and attack on the benzene ring. Because of they have delocalization, the bromine will not be polarized by the benzene ring. So you need some sort of help from any other chemical which can actually convert this into the electrophile. So this will be AlCl3 or FeBr3. Any of these sort of catalysts can actually do the job, and they will make it as a bromine positive ion, which can be used after to attack on the hydrogen. So that will replace one of the hydrogen as bromobenzene. So in the next video, I will actually explain to you the nitration, chlorination, and phenyl car fraction. Please do look at my next video. Thank you very much.